Hello everyone and welcome. Today we're going to be discussing equations. So let's go ahead and get started. So before we begin, we are going to introduce some important definitions. So the first one will be equation. An equation is a mathematical statement that is created when an equal sign is placed between two expressions. And I want you to think about what was an expression? What did it consist of? That was one of our vocabulary words that we discussed in one of the very first videos that we worked on. So if you recall, an expression had numbers or constants. It also had variables, so X, Y, Z's, A's, B's, a letter that represented a number. And it finally had operations, so addition, subtraction, multiplication, division, powers, okay? All the things that we have seen. So an equation is simply two expressions that have numbers, variables, and operations, and they are separated by an equal sign. So let's go ahead and move on. We also know that equations have two sides. So an equation will have a left side. Let me go ahead and annotate that for you. So we will have a left side right here, and we will have a right side. So this equality sign is separating this expression. So our expression here would be 6x plus 2, and it's separating this expression, which is little 8. Okay, so let's go ahead and move on. So in order for us to find the solutions of an equation, we have to replace a given variable into the equation with a number. So, and then once we carry out the operation, whether that's addition, subtraction, power, evaluating powers, multiplication, or division, the resulting statement will either be true or false. Either 1 is equal to 1 or 1 is not equal to 3, something like that. And if it is a true statement, the number is then considered a solution of the equation. But if it is a false statement, then the number is not a solution of the equation. So the best way to illustrate this is for us to try it. So we are going to check the possible solutions of this equation. 4x plus 1 is equal to 9. And we're asked to check to see if 2 and 5 are potential solutions. So our approach here is that we're going to substitute each value into the equation that we're given, and then we're going to simplify and we're going to make a conclusion. Is 2 a solution of the equation, or is 5 a solution to the equation? So let's go ahead and give ourselves some more room. So I am going to separate this so that we have two working spaces, hopefully. Let's see. Maybe that's all we can do. Okay, that's good enough. Alrighty then. So we're going to substitute. So I'm going to substitute x is equal to 2 on this side and x is equal to 5 on this side. My equation is 4x times 4x. So I'm going to put 2 here plus 1 equal to 9. And I'm going to do the same thing over here, but with 5. Whoops. Is equal to 9. Okay, so I'm going to work on the left side. So 4 times 2 will give me 8 plus 1, and that all is supposed to equal to 9. So 8 plus 1 is 9. And yes, in fact, that is equal to 9. So my conclusion is that x equal to 2 is a solution for 4x plus 1 is equal to 9. I'm going to continue on the right side with x is equal to 5. I already substituted, so 4 times 5 plus 1. I'm going to multiply this, so 4 times 5 will give me 20. Then I can add the 1, so 20 plus 1 is 29, and that is not equal to 9. So we can say x is equal to 5 is not a solution is not a solution for 4x plus 1 is equal to 9. So this would be false, whereas over here, this would be a true statement. Okay, hopefully that made sense. And if you have any questions, we can go ahead and answer them. So basically what we did is we were given an equation. Our equation was 4x plus 1 is equal to 9. That 4 is, okay, there, much better. So we have this equation and we're asked to check to see if x equal to 2 is a solution. So what we did is we substituted it in. We substituted 2 for x in the equation. We added the 8 plus 1, and we were checking if this equaled 9, and 9 is in fact equal to 9, so this is a true statement. So we made a conclusion and we said that x is equal to 2 is a solution for this equation. On the right hand side, we were also asked to check x is equal to 5 for this equation. We substituted in 5 for x. We carried out our addition and multiplication, and we found out that 21 is not equal to 9. So we said that this was false and that x is equal to 5 is not a solution for 4x plus 1 is equal to 9. So hopefully that made sense. And we're going to move on to the next example. In this example, we are asked to state if the following is an expression or an equation. So go ahead and pause the video now and attempt these, and then we'll come back and work on them together. Okay, so we have our expressions or equations potentially on the left-hand side of this table, and on the right-hand side, we're going to use our knowledge of our vocabulary. So a good place to start would be for you to write down the definitions of this. So what does an expression have? An expression has numbers, it has variables, and it has operations. Okay. An equation is a mathematical statement where we have two expressions separated by an equal sign. Okay. So that is, you can write out the full definitions, that would be fantastic, but I'm just simply abbreviating it for time. So if we go on to the first one, we have 3x plus 1 is equal to 14. I see my equal sign, I see my expression on the left, so I say that this is an equation. Going on to the next one, I see 7 times y minus 2. There's no equal sign, but I do have a number, I have a variable, I have operations, so I am going to say that this is an expression. Go on to the third one, I have 45 times x. I don't see any equal signs, but I do see a number and I do see a variable, and they are both being multiplied, so I'm going to say that that is an expression. And finally, I have 5x minus 1 is equal to 3x plus 2. I see my equal sign there. I have a left side and a right side. I have an expression here of 5x minus 1, x being my variable. I have numbers, I have an operation, and I have the same thing on the right side. I have 3x, I have an operation, I have numbers. So this looks like I have two expressions that are separated by a equal sign, so I'm going to say that this is an equation. Okay, so hopefully that made sense. And of course, you are more than welcome to write down the full definitions of expression and equation and be able to apply these definitions to these examples. That would be awesome. Okay, so we're going to move on. And now we're asked again to check to see if a is equal to 5 is or is not a solution for the following equation. And our equation is a plus 8 is equal to 13. And our approach is going to be the exact same way. We're going to substitute a is equal to 5 for a plus 8 is equal to 13. In our second step, we're going to simplify. In the final step, we're going to see if it is a true or false statement. So let's begin. We have a plus 8, so I'm going to write 5 actually. 5 plus 8, is that equal to 13? So 5 plus 8 will give me 13, and we want to know, is 13 equal to 13? If I give you $13 and you give me $13, is it the same amount? Whether I give it to you in, 2 5s and 3 1s, or if you give me a $10 bill and $3 bills, is that the same thing? Yes, 13 is equal to 13. So we say, yes, this in fact is a true statement. So you write, true. So our conclusion is A is equal to 5 is a solution for our equation A plus 8 is equal to 13. Okay, so a tip that I would give to you when deciding if this is a true statement would be if the numbers are the same. It would be something as simple as that, but also thinking of values. If I have like 2 is equal to 2, that's true, right? If I exchange 2 apples with 2 apples, that's the same value, so that would be true. But something that would be false would be something like 4 is equal to 1. Well, there are different numbers on the left side and on the right side, so that would be false. But you can also think of it like if I gave someone 4 bananas and they gave me 1 banana back, that would not be an equal exchange. Something like that. Whatever makes more sense to you. I was taught if the numbers match, it's true. But I sort of had to reason this out. Why is this false? And sometimes the best way to apply math is in your own life. So I definitely encourage you to do that. So let's go ahead and move on. And now we're asked to see if a is equal to 5 is or is not a solution for the following equation. So we have 45 divided by a is equal to 9. Our approach is the same. We're going to substitute a is equal to 5 for 45 divided by a is equal to 9. And then we're going to simplify and make a conclusion if a is equal to 5 is a solution. So let's get started. So I have 45 divided by a. I'm going to substitute 5, and we want to know if this is equal to 9. So we carry out our division. 45 divided by 5 is 9. Is 9 equal to 9? Are the numbers the same? Yes, so this would be a true statement. And our conclusion would be A is equal to 5 is a solution for 45 divided by A is equal to 9. Okay, go ahead and jot all that down so that we can continue. Okay, so we are going to check to see if A is equal to 5 is or is not a solution for the following equation. So here we have the same thing. Our approach is going to be the same. I just didn't write all the steps just because we want to make sure that we internalize that problem solving method. So we're going to substitute. So you can write 6 times 5 minus 5 is equal to 15. Actually, you want to see if this left-hand side is equal to the right-hand side. So that's why you write the question mark. So we have multiplication and subtraction. So we just finished our order of operations. So of course, we do our multiplication first. So 6 times 5 is 30 minus 5, is that equal to 15? So now we do our subtraction. 30 minus 5 is going to give us 25. And ask yourself, is 25 equal to 15? Are the numbers the same on the both sides of the equation? And they are not. So we write a slash through the equal sign. So we write false. And our conclusion would be A is equal to 5 is not a solution for 6a minus 5 is equal to 15. Okay, hopefully that made sense. And if you have any questions, why did we substitute 5? Well, we were given a is equal to 5 in the problem, so that's why we substituted it in. Um, why did we do multiplication before the subtraction? Well, we're following the order of operations, which tells us that multiplication comes before subtraction. So that was relevant to our problem. And why are we writing this question mark? Because we want to see if the left-hand side is equal to the right-hand side, because we're checking to see if this solution that we plugged in, if this value is a solution or if it's not a solution. And why did we write this slash through the equal sign? Because this is a false statement. 25 is not equal to 15. And why did we write a conclusion? We wrote a conclusion because we're checking to see if a is equal to 5 was a solution or not. So we are stating that it is not a solution for this given equation. Okay. So that's basically it. If you have any more questions, I'd be more than happy to answer them. And I think for now, that may be the end of our presentation. I thank you so much for being here. I appreciate your time and attention. Next time, we will begin our discussion on the equations practice set so we can get more practice checking solutions for an equation. And I hope that you can join me for that. But for today, that is all. But I do hope that you enjoy the rest of your day.